Hello bachcho, let's read this question. So the question says compute the enthalpy of formation of liquid methyl alcohol in kilojoule mole inverse using the following data. Enthalpy of vaporization of liquid CH3OH is 38 kilojoule per mole. Enthalpy of formation of gaseous atoms from the elements in their standard states are hydrogen 218 kilojoule per mole, carbon 715 and oxygen 249 kilojoule per mole. And average bond energies for CH, CO and OH are given. So let us solve this question, and the key concept is enthalpy of formation. Enthalpy of formation. So enthalpy of formation क्या होती है? It is the enthalpy change when all the elements in their standard state combine to form a molecule in the given state. That means carbon in its standard state, carbon solid plus hydrogen in its standard state, so 2H2 gas plus oxygen in its standard state, एक ऑक्सीजन है इसमें, so half O2 gas combine to form CH3OH liquid. Now हमें ये जो रिएक्शन है इसके स्टेप्स को ब्रेक डाउन करना पड़ेगा. So the steps involved are: first, carbon gets converted to carbon gas with the help of this heat of sublimation, delta SH plus 2 hydrogen get converted to 4H, and इसके लिए जो energy होगी that is again heat of atomization, that is delta S H for hydrogen, and here we have oxygen gas, और इसके लिए भी जो energy होगी that is this one, delta S H for O, और जो हाइड्रोजन है उसके लिए 4 मल्टीप्लाई होगा इधर. नाउ these combine to form CH3OH gas, और इसमें जो एनर्जी चेंज होगी दैट इज द बॉन्ड एंथैल्पी. सो माइनस ऑफ बॉन्ड एंथैल्पी, क्योंकि यहाँ पर एटम से बॉन्ड फॉर्म हो रहा है, एटम से कंपाउंड फॉर्म हो रहा है. जब कंपाउंड्स को ब्रेक डाउन करके हम एटम्स फॉर्म करते हैं देन वी स्पेंड द बॉन्ड एनर्जी, बट सिंस यहाँ पर एटम्स से एक कंपाउंड फॉर्म हो रहा है, सो द मैग्नीट्यूड ऑफ बॉन्ड एनर्जी इज रिलीज्ड. सो यहाँ पर बॉन्ड एनर्जी की साइन नेगेटिव में होगी. देन CH3OH gas gets converted to CH3OH liquid, and for this we have to subtract the heat of vaporization. So delta V, delta vaporization H of CH3OH. So these are the elementary steps in order to get this reaction done. Now let us calculate the energy content of these elementary steps. So the net enthalpy change is delta HR or delta HF, and this is equal to first heat of sublimation of carbon, that is 715 kilojoule per mole. So this is heat of sublimation of carbon plus 4 into heat of sublimation of hydrogen, so delta S H for hydrogen plus heat of sublimation of oxygen. So here these are not heat of sublimations, these are heats of atomization. So this is A H for H, and this is A H for O. This is A and 4 multiplied by, so यहाँ पर delta A H for O minus summation of all bond enthalpies in CH3OH. Summation of all bond enthalpies in CH3OH minus the vaporization enthalpy of CH3OH. Delta vaporization enthalpy of CH3OH. Now values put करते हैं. कार्बन की सब्लिमेशन एंथैल्पी है 218 प्लस 4 मल्टीप्लाइड बाय एटमाइजेशन ऑफ हाइड्रोजन. सो कार्बन के लिए दिस इज 715. दिस इज 715 plus 4 multiplied by 218 plus atomization of oxygen, that is 249, minus summation of all bond enthalpies, that is, so CH3OH की structure ऐसा है, hydrogen, 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 and here oxygen and then hydrogen. So 3 carbon hydrogen bonds plus 1 carbon oxygen bond plus 1 oxygen hydrogen bond. So 3 multiplied by bond enthalpy of CH plus bond enthalpy of OH plus bond enthalpy of CO minus vaporization of CH3OH, that is 38 kilojoule. So this is equal to 715 plus 4 multiplied by 218, that is 872 plus 249 minus 3 multiplied by bond enthalpy of CH, that is 3 multiplied by 415, that is 1245, minus bond enthalpy of OH is 463 minus bond enthalpy of CO is 356 minus 38. So this value is equal to minus 266 kilojoule per mole. So the enthalpy of formation for CH3OH in the liquid state will be minus 266 kilojoule per mole. This is the required answer, and I hope you understood the concept well. Best of luck.